Hi everybody, my name is Chiara and in this tutorial I will show you how to configure the Inxpect safety radar equipment in an easy way. We will be setting up a system composed of two 200 series smart sensors and one 200 series control unit, equipped with an Ethernet field bus. Inxpect safety products are the first Seal 2 PLD and UL listed radars in the world. They provide advanced operator safety in dangerous areas through access detection and restore prevention functions. Now, let's see how to connect the system and complete the initial setup with the Inxpect safety application. We'll start by connecting the control unit to the power supply. Then we connect it to the first sensor. After this, we connect the first sensor to the second one, and so on. It is possible to connect up to 6 smart sensors to each control unit. The Inxpect safety application can be downloaded through the Inxpect official website. Now that the software is downloaded and installed, let's first select the desired language. Click on the drop-down list at the right-hand corner of the screen. Let's have a look at the main part of the page. We have 3 scenarios for the device connection: the Ethernet connection, the USB connection, and the system simulator mode. But which one do we choose according to our needs? Let's find out. The choice between Ethernet and USB connection is based on the cable availability, and obviously with respect to the control unit model, whether it is provided with an Ethernet port or not. To connect the control unit to the computer via Ethernet, we take a standard Ethernet cable and insert it in the correct port. In order to communicate with each other, the computer's IP address must be in the same subnet of the control unit. In this example, we connect the Ethernet cable to the control unit and the computer. As we can see at the top right-hand corner, there is a Discovery tool. The Discovery tool automatically searches on the network for available Inxpect devices. The model of the detected product is shown right here with its NID identifier and its current IP address. The checkbox means that the control unit is reachable, and we can now connect to the device by clicking here. Otherwise, a triangle with an exclamation mark means that it is necessary to either change the IP settings of the computer so that it is in the same subnet of the control unit, or connect via USB. After the first connection, the system can also be configured remotely. If we choose to connect with USB, instead we need a USB to micro USB data cable. A charging-only cable won't work. Connecting it to the correct port of the control unit. To complete the operation, just click on the Continue button. That's it. Keep in mind that if we use a Windows computer, we need to download and install a specific driver to recognize the control unit. Such a driver is available for download at the same link of the Inxpect safety application. The system simulator mode allows using the software even when you don't have a physical system at your disposal. In other words, it is possible to create a configuration without physically connecting to the device. In this way, connecting the device on site will make it easier to load the prototype configuration and refine only the details, instead of starting from scratch. You can find further information right here: Resources and Tools. Identify system specifications. This comes in handy in case of problems, since it allows identifying the system depending on the version of firmware and software you have. These specifications help our technical support team understand what is not working and how to solve the issue. This other option allows upgrading the system's firmware to the latest version. It does not involve any connection to the internet or any download. It is only a wizard containing the software that automatically upgrades the control unit. Now, let's get down to business. Connect the device and enter the system configuration. We select Ethernet connection and click on the device detected by Discovery tool. A wizard, that is a guided process for the configuration, opens and it divides into the following points. We need to choose a password for the control unit to log in as an administrator and configure all the features. We have to choose which and how many sensors to connect to the control unit. In this case, we have two 200 series sensors, model S201A. We have to select the country where the system will be installed. Be careful and select the correct country to comply with that country's national regulations. We must select whether the sensors are placed on a fixed machinery or on a moving vehicle to comply with the product's certification. Well done! Configuration completed! Now the system will work for a few seconds to save the settings. In case we made a mistake in the configuration, just reset to factory defaults in the settings and repeat the wizard. This is the main screen of the Inxpect safety application. To continue with the configuration of your devices, watch the next video. Thanks for watching! See you soon! Hi everybody, I'm Chiara and today I'm going to show you an overview of the Inxpect safety application. Firstly, let's see what the application page looks like. There is a navigation bar at the top with items that I will describe later. At the top right-hand corner, a button allows disconnecting from the control unit, and an admin button allows logging in either as an administrator or a regular user. In this latter case, the user will only be permitted to view the current configuration, as opposed to having full modification privileges as an administrator. Now, let's take a look at the menu items. The dashboard summarizes all the key system parameters, such as the system status, digital inputs and outputs, and other settings. The configuration page is where we set the working parameters of the sensors, including the detection distance, the angular coverage, the safety working mode, and the restart timeout. The settings page contains various system settings, such as digital input-output configuration, network parameters, fieldbus and modbus parameters, activity history, as well as many other features that will be covered in the next videos. The validation page helps show the detected targets and have related information in real time. This is super helpful to make sure that the installation is performing as expected. The left-hand side of the dashboard shows the status of each system component. In this example, we have one control unit and two sensors. The color of each icon status indicates the status of the component. When orange, it means that the system has yet to be configured. If it's green, the component is working properly. Finally, red indicates an error. The first time we log in, the icon status next to the device is orange. Let's see how to take care of this. We just need to configure the system. The Apply Changes button will commit the changes we made to the system and transfer them to the control unit. Otherwise, if we're not satisfied with the changes, we just need to click on the Refresh Configuration button and try again. In the center of the page, we can find a list of all the digital inputs and outputs, with all the functions assigned to them. On the right-hand side, there is a summary of the current settings. For an in-depth overview of the configuration of Inxpect devices, don't miss the next video. Thanks for watching! See you soon! Hi everybody, I'm Chiara, and in this video I'm going to take you through the features of the configuration page. The configuration page lets us set all the working parameters of Inxpect sensors, such as the field of view, the number of detection fields, and the safety working mode. But let's take a closer look at the page itself. In the configuration page, we find a whiteboard useful to represent the current configuration of the sensors. We can add more sensors to our installation by clicking here. Remember, the whiteboard can be resized at your convenience. Clicking on the change symbol will determine whether the aspect ratio of the image will be kept or not. It is possible to import to the whiteboard an image representing the layout that can be appropriately scaled. Note that the layout we create in the whiteboard can be exported and used later. The graphical parameters allow us to represent the position of the sensors, as well as realize the way we monitor the hazardous area. Let's see how. By selecting each sensor, we can choose the spatial position and rotation around each of the three axes. As an alternative, we can use the mouse to move and rotate the sensor. By doing so, bear in mind that it's possible to operate only the rotation with respect to the y-axis, while rotation around the x and z axis is managed from the menu under the whiteboard, as mentioned before. For each sensor, we can modify all the operating parameters shown in the menu on the right-hand side of the screen. There are several detection fields that can be configured individually. For example, the Smart Sensor 200 series has up to 4 detection fields. For each of them, there are 3 safety working modes that we can choose from: Always On Access Detection, Always On Restart Prevention, or both options. We can also choose the detection distance and the angular coverage of the field of view. And we can enable the static object detection option and the restart timeout. Remember that for the Smart Sensor 200 series, the restart prevention function is deemed safe only with timeouts of 4 seconds or longer. Please note that it's possible to create multiple configurations of the sensors and switch dynamically among them in a safe way, via digital inputs or field bus. This drop-down menu serves exactly this purpose. It allows us to add, duplicate, and delete configurations. Once we finish making changes, click on Apply Changes in order to save them on a control unit and activate them. After this, a configuration report will be shown. The reports are documents that cannot be changed and can only be printed and signed by the Machinery Safety Manager. We can find these documents also in the Configuration Reports archive. A couple more details. If you want to remove a sensor from the configuration, we can click on the Delete Sensor button. Otherwise, if we need to identify the sensor to configure, we can click on the Identify by LED button. Subsequently, the LED of the corresponding sensor will start flashing for 5 seconds, allowing you to identify it. Alright, we have configured our first sensor. To find out more on how to proceed with the settings, watch the next video. Thanks for watching, see you soon! Hi everybody, my name is Chiara, and in this video I'm going to take you through some of the features of the settings page of the Inxpect safety application. That is to say, the General section, the Node ID assignment, and digital input-output. Before we start, note that in order to modify all the settings, you must be logged in as an admin. The top right part of the menu shows your current access level. This section shows the model of the control unit and its network identifier. This identifier helps understanding which control unit we are connected to. The firmware version of the control unit is also displayed together with the information about the connected sensors, their model, sensor identifiers, and firmware version. The lower part of the page shows a list of the system parameters and the buttons to perform a system backup in order to save the configuration on the computer or restore a pre-existing configuration. Finally, a factory reset button reverts the system to its factory default settings. The Node ID assignment section is where each connected sensor gets its unique identifier, which in turn allows the control unit to recognize and identify the sensors along the chain. You can quickly recognize sensors without an identifier. Their LED will flash twice. There are 3 ways to assign the Node ID to a sensor: automatic, semi-automatic, and manual. Let's start with the first 2. When we click on the Assign Node IDs button, there are 2 different modes to choose from: automatic or semi-automatic. In automatic mode, the node IDs are assigned to connected sensors in one shot, without following the order of the sensors along the chain. In semi-automatic mode, a wizard guides us through the connection to the control unit of one sensor at a time. In this way, we have complete control over the assignment of the node IDs to each sensor individually. Now, let's look at the third and last mode, the manual one. In order to proceed with the manual mode, click on the Discover Connected Sensors button. A list of sensor identifiers of the connected sensors is shown here, together with their node ID assignment status. Furthermore, in the Actions column, we can see that the action Assign is now available. Starting from the first line, click on Assign and choose the sensor identifier of the desired sensor. Repeat this action for all the configured sensors. Once a sensor is assigned a node ID, its LED turns steady blue. The digital input-output section is dedicated to the configuration of the functionality of each input and output of the control unit. For each input, there are several options: the muting and restart signals, the stop signal, which means that the input is configured to be connected to an emergency button, forcing the deactivation of all the safety outputs. The fieldbus controlled input allows monitoring the input status via fieldbus, and the activate dynamic configuration allows switching configurations dynamically. Let's take a look at the output options. The 4 detection signals, in which each signal is useful for reporting the status of the corresponding detection field to an output. Remember that, in order to ensure the system safety level, each detection signal must be identically reported on a dual-channel safety output. The system diagnostic signal can be used to report a system fault. The fieldbus controlled output allows monitoring the output status via fieldbus. And the muting, enable, and restart feedback signals will be described in the next video. After choosing the function of each output, we can choose the pulse duration at 0 volt of the signal, used at the receiver to detect a short circuit. Great! That's it for today! To proceed with the other features of the settings page, don't miss the next video. Thanks for watching! See you soon! Hi everybody, I'm Chiara, and in this video I'm going to introduce you to the configuration of the following system functions: muting, restart, and anti-tampering. Let's start with the muting function. Muting is an optional safety function that allows the control unit to ignore the detection from a selected group of sensors. The upper part of the page is used to configure the groups of sensors that will be affected by the muting function. In this example, there are two configured sensors, which we can then associate to a group at our discretion. After this, let's move on to the digital input-output. Each group can be independently muted by a digital input. Keep in mind that the SNS and ground inputs must also be connected if at least one input is connected. Instead, regarding the configuration of the outputs, it is possible to select the muting enable feedback signal to have feedback when at least one sensor is in muting condition. Lower on the page, we can configure the muting signal so that the function is enabled only if both logic signals of the dedicated input meet specific characteristics. That is, pulse width, signal period, and phase shift. Let's now take a look at the restart function. The system manages 3 types of restart prevention for each detection field: automatic, manual, or safe manual. Let's analyze them in detail. The automatic type does not require the operator to take any action. The system automatically reactivates the safety outputs once the area is clear of movement. In the manual type, the safety outputs are reactivated by an external restart signal that can be a button pressed by the operator. The safe manual type is the combination of the two functions just described. The sensors perform the restart prevention function and then wait for a restart signal from outside the system. Here you can assign the desired type of restart prevention function to each detection field. As we can see from the warning message, if the selected restart function is either manual or safe manual, we need to go back to the digital input-output section and assign a restart signal to the digital input that we want to use for this purpose. It is also useful to configure a digital output by selecting the restart feedback signal, so that it gives us feedback when there is no more movement in the area and the operator can manually restart the system. This section includes the anti-tampering functions of the system, which can be configured for each sensor individually. The anti-tampering functions are anti-rotation around the axis and anti-masking. Let's see together what this is all about. The anti-rotation function can be enabled to detect a change of the rotation of the sensor around each individual axis. Tilt is the rotation around the x-axis. Pan is the rotation around the y-axis, and roll is related to the z-axis. Let's now focus on the anti-masking function. This is used to detect if an object occludes the field of view of a sensor. This function can be enabled individually for each sensor. Two parameters control its response: sensitivity, which is low, medium, or high, and the maximum detection distance. Please note that a click on the Apply Changes button at the end of the configuration will save the parameters for both anti-tampering functions. Here we are, guys! If you want to discover the latest features of the settings page, don't miss out on the next video. Thanks for watching! See you soon! Hi everybody, I'm Chiara, and in this video I will introduce you to some of the most advanced features of the settings page. Let's start with the network parameters. If the control unit is equipped with an Ethernet port, this section allows us to assign an IP address to it. There are 4 network parameters, and these are the IP address, the net mask, the gateway, and the TCP port. Once the parameters are all set, click on the Change Network Parameters button in order to apply the changes. The fieldbus parameter settings are found in the section bearing the same name. These are the data encoding contained on the exchanged messages and the addresses in which the control unit reads and writes data. In particular, ProfitSafe requires that the F modules have a unique address within the network. It is possible to configure these addresses in this table by inserting them under the version of the connected PLC. The Change Fieldbus Parameters button is used to commit the changes to the control unit's memory. If the control unit is provided with an Ethernet port, the Modbus Parameters section is used to enable communication with the control unit via Modbus, along with the related listening port. As usual, click on the Change Modbus Parameters button to commit the changes to memory. Finally, let's take a look at Advanced section. The multi-control unit synchronization ensures that there is no interference between multiple Inxpect systems deployed in the same area. In this example, it will be enough to set a different channel for each of the control units. The detection fields dependency parameter will determine whether a movement sensed in a specific detection field will lead to the deactivation of just its own output or also of the ones related to the detection fields that follow. In the Activity History section, we can find the log verbosity level, which allows configuring the level of detail of the internal log data, a Download Log button, that we can use to download the log from the control unit, which contains information events and diagnostic events. The Erase Log button allows us to delete the Information Events section. In case it's not deleted, the oldest information events are overwritten when the maximum size of the section is reached, that is 3500 events. There is also the Download Sensor Debug Info button. This allows downloading a zip file useful for debugging where requested by the Inxpect technical support team. Finally, the Configuration Reports archive. which allows us to access the archive of previous reports and download the related PDF files to the PC. In this section, we can find a list of configuration checksums. Let's look at them together. The configuration report hash is a unique alphanumeric code computed by taking into account not only the entire configuration, but even the information which makes up the report, such as the details of the commit. On the other hand, the dynamic configuration checksum is associated with a single configuration and considers both common and dynamic parameters. For example, it is useful to verify that at a certain time a specific dynamic configuration is actually enabled. In the Accounts section, we can change the language of the software and the admin password. Here we go! That's it for the settings page. If you want to know more in detail about how the validation page works, don't miss the next video. Thanks for watching! See you soon! Hi everybody, I'm Chiara, and in this video I will take you through the features of the validation page. The validation function is useful to visualize in real time the position of a target in a monitored area, for example, during the first installation of the system. On this page, we find the following information: the position of the first target detected by each sensor. In any case, the information can be deleted anytime with a specific button. The position of the target detected by each sensor in real time, the system status of each component, the dynamic configuration that is currently active, the status of the digital inputs and outputs. Note that the image shows a single target for each detection field of each sensor. If the target is moving, the dot is empty. Otherwise, if it's static, the display dot is full black. Alright people, that's it! We hope you enjoyed it and found it helpful. For any further assistance, do not hesitate to contact our technical support team. Thanks for following us! Bye bye!